Okay, let's continue to move on to a new section, 5.3. In this section, we study two important measurements on the performance. The first one is the so-called dollar valued in interest rate, and the other one is time weighted interest rate. So here the goal is to evaluate the performance of an investment fund or a fund manager. We begin with a rather simple example, and from there we will get, hopefully we get more information about the purpose of this section. Now let's look at the rather simple example, okay? So assume we have a fund manager, or there's a specific fund that has $1,000 at the beginning. So in the first year, it makes 20%. So it goes up to 1,200. But in the next 2 years, the performance is only 5%. So this is the given information. From here, we can easily calculate the accumulated value at the end of 3 years. So that would be 1,000 times 1 plus 20% times 1 plus 5%, and then times by 1 plus 5%. So here what we assume is the money does not leave this fund, right? So we start with 1,000. By the end of 1 year, we will have $1,200. The extra $200 will be reinvested in the same fund, earning the same interest rate. So in the second year, we will have $1,200 earning at 5%, and the same, for the final year. Okay, we will be able to compute this number quite easily. So we will have $1,323 by the end of 3 years. So if we assume there is a interest rate that is applied equally to 3 years, what we would set up would be, right? So assume the same interest rate for 3 years. So from here, we can roughly get the number to be about 9.7792%. So by the way, this is the same concept as internal rate of return, right? So this is the same interest rate we introduced previously when we studied the NPV method, right? Here we are able to do this. An important reason is because there is no cash flow in, there's no cash flow out, right? In any time. So at time 1, at time 2, at time 3, or anything in between, there is no money in, there is no money out. So it's relatively easy to see that this is a good way to measure the overall performance over the 3 years, right? So note that in mathematics, we can't say this is the geometric. Right. So the arithmetic average, everybody knows, right? So what is the arith? That is simply to add everything together and divide by the total number. So if you have I1, I2, all the way to IN, this is the arithmetic average, right? The geometric average is what is defined above. So what you have is this. This is the so-called the geometric average. But sometimes, things could get a lot more complicated when there is, extra deposit, or there's something, there's a withdrawal, right? So this is an easy example. Now let's look at something more complicated. So we still have pretty much the same thing, but let me get different color to demonstrate what would be the new changes. So now assume that by the end of year 1, there is an additional contribution of $5,000. So now things would be a lot different, right? So now I use I use the blue color. So the same thing, still applies to the original $1,000, right? So in the end, we will still have this. This is the same. Okay, but we have additional $5,000 deposited by the end of year 1. For this amount, it will accumulate for 2 years at the interest rate of 5%. So now what we have is $6,835.50. So now the question is, we wouldn't be able to apply this method, right? Because, well, we don't know the present value, right? We can't use 1,000, right? Because obviously, using 1,000 to get a imaginary rate, it's unrealistic, right? It does not give you a good idea of the performance of this particular fund, because this value is so big than the original one, not because we have done anything different in the second fund, right? The reason why this value is so much bigger is because there is additional contribution. So in this case, how do you evaluate the performance for those two managers, right? The manager number 2 does not do anything worse than manager number 1, right? So in fact, the strategy is the same, because if you look at individual years, well, the performance is exactly the same, right? Nothing changed. The only new thing is you get new contribution at the end of year 1. So technically speaking, you should rank equally for those two funds based on the performance at each year over the evaluation, right? But if you only look at the end value or the accumulated value, you might arrive at a completely different conclusion, right? Because if you only look at the beginning and look at the end, well, you'd say fund manager number 2 did a wonderful job, right? Then the manager number 1, right? Which is not the case. So now what can we do? One way we can do is, well, we still assume the same, right? We still assume we have the same effective interest rate, but when we establish the equation, we will need to do this, right? And then equate to 6,835.50. So you have to account for this additional contribution, and this contribution is accumulated for 2 years. That's why I times it by 1 plus I to the second, right? So that's the 2-year accumulation factor. I have to account for both of them. Then this is a cubic, equation, right? Because the highest term is in cubic. We can solve this, although it's slightly more complicated. Anyway, assume that your financial calculator gets you this answer. Okay, 6.19%. So this, if you compare to the original one, we have confusion, right? As I already mentioned, those two funds pretty much are the same fund, right? The return in each year is exactly the same. 20% in year 1, 5% in year 2, and 5% in year 3. But we actually arrived at different results, right? In the first case, it's nearly 10%. In the second case, it's about 6%. So the difference is quite striking, right? And that's the reason we want to study more, right? What we applied here is what we usually refer to as dollar weighted. Okay, that's because we take into account the impact of all the dollars, right, or the account value, right? So this is the original account value at time 0. This is the additional contribution to the account value we take into account, right? So when we calculate dollar weighted interest rate, so this is how we perform. So now let me summarize the definition, how it is defined. So assume at time 0, the fund value is F0, and then I will have some contribution. Okay, so if C1 is positive, that means this is a deposit. If C1 is negative, that means it's a withdrawal. So at this moment, we don't know the sign. Right, so well, you know, we can have contribution in the very end as well. So here's Cn minus 1, here's Cn. So in the end, my fund value is Ft, okay, after the final contribution. So now let's assume there exists a unique interest rate, a unique which is equal in each year, so that I could establish this equation. So again, you know, this interest rate I does not really exist, right? It's something, you know, I'm trying to define, or sometimes we can call this imaginary interest rate. So F0, if such interest rate exists, when I accumulate to the end, also here's T. To the end, it would be the original time, original value times the accumulation, right? Okay. So here I don't know when my last one is. So I'm just trying to follow exactly the setup of our textbook. So the total time would be T, capital T years, but the contribution could be any time in between. Does not even need to be exactly 1, 2. Although, you know, time 1 year, 2 year would be easier to do, but it does not have to be that way. It can be any time points between the starting time 0 and the ending time capital T. So for C1, it would be 1 plus I. Okay, so it's from this time to the end. So it would be capital T minus T1. For T2, it would be capital T minus T2. For T3, it would be 1 plus I to the power of T minus T3. Okay, goes on to Tn. Okay, this would be my final fund value. So if such an equation has a solution, that would give me, so let me write it in a more uniform way. Let's not use I, because I is interest rate. So textbook use S, so let's follow it. S from 1 to n. So here's CS, 1 plus I to the power of T minus TS equals FT. So the solution I would be dollar weighted interest rate. And the reason why we call it dollar weighted, that is because we actually take into account the impact of each cash flow towards the very end, right? So this is counted for the actual contribution at those T1, T2, all the way to Tn, okay? Those times we actually consider their impacts. So that's why it's dollar weighted. So the actual dollars coming in or leaving the pool could make a difference to the actual interest rate we are trying to define, right? And as we can see from the example down here, using dollar weighted sometimes gives us a false, you know, intuition, right? Because so far, this and this are dollar-weighted interest rate, right? This is exactly what we did using this general formula, right? But in the end, those two funds are identical, but we arrived at two different interest rates. We have about 10% for the first one, about 6% for the second one, right? And that's probably not ideal, right? Because two managers did the same thing. So that motivates us to consider something slightly different to isolate the impact of additional cash flows. Right? So we simply want to evaluate the performance of fund managers, right? But we don't want, say, the actual contributions or additional withdrawals affect the evaluation, because that shouldn't, affect our judgment, right? It's possible that one manager gets a huge contribution, or the other manager, he just lost some of his big investments. Those shouldn't affect the judgment, right? We should only judge on the performance only, right? Those, whether someone joins or someone leaves is not something the fund manager can decide, right? The fund manager can only decide on how he or she invests the fund into different stocks or different financial products. Managers cannot control the money in or the money out, right? They cannot control those additional cash flows. So if we isolate, how can we evaluate? Then those would be, so first of all, let's start with some notation, okay? So the setup is the same. So at time 0, we have F0. At time t, we have Ft. And we also have different contributions, or can be withdrawals depending on the sign. Okay, now let's do something different. Okay, so F0 goes to, here would be, so let me put sign down here. So this is F1. So the meaning of F1 is the account value right before the cash flow C1. So this is before. So technically speaking, those should be the account value before the injection or withdrawals. Okay. Similarly, we can also do the same thing for F2. Ftm minus 1. Okay, and then let's define time weighted. So again, we assume there exists a unique value I for each year, but here it would be F1 divided by F0. This is exactly the return, right, from 0 to T1. So F1 is actually T1. So although sometimes I feel the better notation would be better notation might be Ft1 down here. So F1 is the account value right before the cash flow C1. Okay. Next, since there is a cash flow at C1, so I actually need to add this, right? So this becomes my new account value at T1, right at T1, or right after the additional cash flow C1. Okay, so this would be my starting value for the next period, and it goes to F2, right, before the next cash flow C2. So we do the same thing. So F3 should divide by F2 plus C2. Okay, goes on and on. Finally, Ft divided by Ftn plus here. This is not. So this is CN. So this is obviously a totally different definition, right? So by using this, let's say what do we have for the previous one? Okay, the results are here. So we know before the injection, we know the 1 plus I, so 3 years. So this is easy to establish. Before the injection of 5,000, we will have how much? We will have 1,200. Okay, and then we have, well, let me write down the summation term. Okay, here you need to, well, we can write here as F2. Well, we don't need to do that because there's only one. In the end, what is the value? In the end, the value is about 6,800 and 33, 35, 0.50. Okay, if you have calculator, you can easily do the computation. So let me compute. Divided by 6,200 times by 1.02. So this is, okay. Then I need to take 1/3 as the power minus 1. Then I will get my interest rate is about 9.779%. Then, you know, if we go back to the original one, right? You see that it's the same. Actually, if I keep 4 decimal, it would be 7792, right? So this is good, right? Because by applying this, we get the same result. That is our intuition, because those two funds are exactly the same, right? 20% in year 1, 5% in year 2, 5% in year 3. They are identical, meaning no matter what kind of measurement you apply to measure the performance of those two fund managers, you should arrive at the same result. We already saw that by applying the dollar-weighted return, we arrived at different results. But if we apply here time-weighted, we get the same result. Okay, so that is the pretty much the definition part. So let me finish this video here, and in the next video we focus on examples, right? So in this video we pretty much defined those two important interest rates, right? Time weighted and dollar weighted interest rates. In the next video we continue our study through examples.